We are taking R.D. Sharma Solutions, Class 11th, Chapter number 3, Functions, Exercise 3.1. First question is, define a function as a set of ordered pairs. So when we have two sets A and B and they are non-empty sets, that is, they contain something, then the relation F from A to B, it is a subset. All these ordered pairs which are coming here will be belonging to A cross B. That is, it will be a subset of A cross B, Cartesian product of A cross B. This is called the function or a mapping from A to B. And the main thing which need to be understood is, if we have this A and B, then one A means one element of A will only be related to one member of B. You cannot have two members of B related to A. This is the crux, this is the main idea behind a function. And it is being said here also that if A comma B is F, that is A is related to B, and this B is called the image of A. B is called the image of A. So if A comma B belongs to F and A comma C also belongs to this function F, then this will be only function when B is equal to C. There cannot be two, you can say, image of any element of A. So this B and C has to be 1. They has to be 1. B and C has to be equal. This is the crux. Define a function as a correspondence between two sets. So correspondence, again same thing. Correspondence means mapping, correspondence means association, correspondence means a rule or a method or a correspondence which associate a member of A to member of B, and these members will be ordered pairs and they will only belong to A cross B. That is the Cartesian product. So the main thing is that only one element of A will be associated only with the one element of B. You can have two elements of A that can be associated with one element of B, but you cannot have one element of A associated to this also and associated to this also. It cannot be there. So if you find, say, 2, 3 and say 2, 6 in any, just example, in any of the this function, this is not a function. Why? Because the first member of this ordered pair is repeated, which is not possible. You cannot have a single value having different images. So this is not possible. This is the only mapping or correspondence. What is the fundamental difference between a relation and a function? Is every relation a function? So first of all, a relation is what? If you take two set A and B, relation will be all the ordered pair sets which are subset of A cross B. So any number of element can be in A, any number of element can in B. So you can have a cross product of these two, and when you have a cross product, you have different types of different ordered pairs. So relation is a bigger set and function is a smaller set. It is inside relation. So a function will be a relation will not be always a function. Why? Because a function means every function, that is every element. See here, that if it is a function, then every first element will have a unique image. Here there are two images. One is related to 1 is related to 2 also, and one is related to 4 also. This is not possible. So this is the possibility only. This is the possibility only. It can be only in a relation, but in function it is not done. This is not acceptable. Now A is given as, in this question, A is given as -2, -1, 0, 1 and 2. And the f function is from A to Z. That means from this A set to Z. Z is the integer. And the function is defined by, the function is fx. It is defined by x squared minus 2x minus 3. It is defined like this. We have to find the range of f. So how to find out the range? Because this is showing the domain, and whatever value it corresponds to in this set, that is integer, all the values this correspond, whatever we feed in -2 here, whatever we feed -2, -1, 0, 1, 2 here, and whatever values are coming, those are going to be the image. Okay, so we'll start with -2. We'll put -2 here. I'll just give you an example of this one so that you understand how we have done this. So I'll just put x as -2, x is -2, -3. So -2 whole square is 4, minus is plus, so it will be 4 and -3. 8 minus 3 is 5. So you get f -2 as 5. Now you put -1, f -1 will be 0. You put 0, f0 is -3, f1 is -4, and f2 is -3. So all the values of a, when they are put in this function, you get 5, 0, -3, -4, and -3. So the set of these elements which have come, these are the range. These value will correspond to, and they will make or constitute the range. Okay. Now, what are the pre-images of 6, -3, 5? So 6 has come where? 5, 0, 3. Because 6 is already not there. 6 is nowhere. So 6 cannot come. In this function, if you put these values, 6 is never going to come. So the pre-image of 6 is nothing, that is 5. What is the pre-image of -3? -3 has come where? -3 has come when we put f equal to 0, that is 0. -3 has come when we put this value as 2, so 2. 0 and 2 are the pre-images of -3. 5. When has 5 come? When has 5 come? Let's see. 5 has come when we put -2, so -2 is there. Any other value where this 5 has come? No. So -2 is the pre-image of this 5. In this question, we have a function f from R to R, that is real number to real number, and this is defined as this one. That is, if you take this one, say x equal to 0, then you have 1. X equal to 0, it is 1. If x is less than 0, that is this side, it will be 3x minus 2. So there are 3 partitions at this one, and now we have x is greater than 0. So this partition. So now here everywhere you will use 4x plus 1. So we have to find f1, f minus 1, f0 and f2. So f1 will be what? f1 is positive. So 1 will come here. That is 1 will come positive. So this will become here. 4x plus 1 you have to use. 4 into 1 plus 1. So you get 5. So f1 is 5. So coming to f minus 1. Minus 1 will be less than 0. Minus 1 is less than 0. So you will go here, and this option you are going to use. 3 into minus 1 minus 2. That is minus 3 minus 2 minus 5. f0, because it is given, then when x is equal to 0, what you are going to get? Always 1. So it will be 1. How about f2? f2, that is, you have to put 2 here. Now 2 is positive, so you will put it in 4x plus 1. 4 into 2 plus 1, that is 8 plus 1, 9. This is going to be 9. A function f from R to R, real number to real number, where R plus is the set of all positive real numbers. R means real number, plus means all the positive real numbers. And this is such that, no, this is not. The question is, this I just told about the next question. Let me take you back to the previous question. That is, f is R to R, and this is defined by fx equal to x square. We'll deal this R plus in the next question. So fx equal to x square. We have to determine the range of f. What is the range of f? And what will be the, and there are 2 other options we'll see just now. First, let us find out the range of f. What is the range of f? You have to put all the real numbers. So whenever you put all the real numbers here, any real number, say minus 1 I am putting, square is 1. 1 I put, it will be 1. So always it will be positive. So the range of this function f, that is the value which are coming, will always be positive because it is x squared. Anything squared will always be positive. So you just write R plus. R plus means, this is what I was discussing about, set of all real numbers. They may be 0 or it will be greater than 0. It can never be less than 0 because it is x squared. Next one is x is such that fx equal to 4. So now fx is given as 4. Fx is what? It is x square. So x square equal to 4. So x square equal to 4. So x will be under root of 4 plus minus, and this is going to be plus minus 2. So we have minus 2 and 2 are the result of this this expression. Now y such that fy equal to minus 1. Fy equal to minus 1. So it doesn't matter you use y, z or x. You just have to put this x square here. So fx is equal to x square. So fy will be y square. So what do you get? Just put y square here. But we see, because we don't know the complex number as of now, we understand that we have not learned, or just forget about the complex numbers, because this problem is dealt in complex numbers. But we don't know complex numbers right now. And in this view, y square cannot be negative. Anything square cannot be negative. So you will have phi. The result of this one is phi, nothing. This is not possible, because x square is always greater than or equal to 0. Here this f is from r plus to r, that is all the positive real numbers to real number. This r plus is the set of all positive real numbers, and this is given by fx equal to log e to the base x. So whenever we write this log, what does it mean? When we write log a b, base is a, b is there, and it is c. So it just means a to the power c is b, a to the power c is b. This just means like this. So now first one is, we have to first determine the image set of domain of f. Image set of domain of f. So it's quite simple, because it is given that the R is going to be the image set. So whatever you put here, it will always be real number. So the image set of the domain of f, that is the image set of domain of f is already given as R. So you just write R. It doesn't matter, because all real numbers, the image set of domain of R will always be, because whatever you put, it will always come as a real number, because log always give you real numbers. So this is sorted. Next is fx equal to minus 2. So when you have fx equal to minus 2, that means you have to put this one, fx is this one. So log ex equal to minus 2. So as I said here, a to the power c, that is e to the power minus 2 will be equal to x. So x will be e to the power minus 2. So the solution is e to the power minus 2 for this one. The third one is whether fxy equal to fx plus fy. So let me write fxy. No, x into y. This is x into y, not xy. X, it is xy, right? It is equal to fx plus xy. Let me see. Fxy is what? Now, this is fx log ex. Here I have to put xy in the place of x. So log base e xy, and this is equal to fx is what? Log base ex, and what is y? Log e base y. So we know that log m into n is equal to always log m plus log n. This is the property of log. Log m into n is log m plus log n. So log e to the base xy is nothing but log x plus log y. So this is also true. So this, they have asked whether it is holding or not. You say okay, this holds, this is true. Write the following relations. There are certain relations being given. So you have to write this relation as sets of ordered pairs and find which of them are functions. So we have y equal to 3x, and here it is given x as 1, 2, 3 and y as 3, 6, 9, 12. So what we will do, this we have to put x as 1, 2, 3. So let us put 3 into 1. So x I am putting 1, then 2, then 3. So what do we get? 3, 6 and 9. So 3, 6, 9 are the only values we are getting from here. 12 is not there. So what will be the ordered pair? 1, 3, that is 1, 3, 2, 6 and 3, 9. 1, 3, 2, 6 and 3, 9. And why it is a function? Because all these first member are different. Just you have to see, first member have to be different, and the first member should belong to this one, second member 3, 6, 9 belong to this one, and there should not be any repetition in the first member. That is the only definition of function. Next one is this y is greater than x plus 1. Y is greater than x plus 1, and x is given as 1, 2 and y is given as 2, 4, 6. So here y is greater than x plus 1. So just put x equal to 1 here. So when we put x equal to 1, y should be greater than 2. And what are the values here? Y which is greater than 2, it is 4 and 6. So 4 and 6 are here. So what do we get? This when we put x equal to 1, so 1, 4 and 1, 6. So 1, 4 and 1, 6 are the ordered pair. Then coming to, let us put x equal to 2 now. So y is greater than, x is 2, I am putting 2 plus 1. So y is greater than 3. So what are the values here which are greater than 3? 4 and 6. Again you get 4 and 6. So you get 2 and 4 because we have put x as 2. 2 and 4 and 2 and 6. 2 and 4 and 2 and 6 will be the ordered pairs. Next one is x plus y equal to 3. And x and y, they both belong to 0, 1, 2, 3. So x will belong to this set 0, 1, 2, 3, and y also belongs to 0, 1, 2, 3. So let me just rearrange this expression or equality. Y equal to 3 minus x. Now I'll put x as 0, 1, 2, 3. So 3 minus 0, 3 minus 1, 3 minus 2, 3 minus 3. So what do you get? 3, 2, 1 and 0. So what do we get? 0, 3, 1, 2, 2, 1, 3, 0. So these are the ordered pairs. And it is also a function. Why it is a function? Because we have all these values, first values are different and all belongs to this set, and the second value also belongs to the second, all the second values belong to this set. Let me tell you here also, because we have not checked for the function also. See, the first value is repeated. The first value here also repeated. So 1 is repeated, 2 is repeated. So it will not be a function. It will not be a function. So the B part is not a function. A and C are functions. Let F, this F is from R to R and G is from C to C. So you can have, you can assume it to be a real number. It can be any number, complex number you can say. So the question being asked is, if Fx is equal to x square and Gx is equal to x square, then are they equal functions? Are they equal functions? They are not equal functions. Why? Because the domain of F is R, real numbers, and domain of G is some C or complex number, anything you can say. So the domains are not equal. So the value you are putting here will not be equal. You will put real numbers here, you will put some complex numbers here. So the domains are not equal. When the domains are not equal, these functions cannot be regarded as equal functions. They are unequal functions. Next is, if f, g, h are three functions defined on R to R. That is f from real number to real number. Fx equal to x square, gx equal to sin x, and hx equal to x square plus 1. This one. So you have to find the range of each function. So whatever you put here, x square, any real number you put, say I put minus 2 and I put plus 2, x square. This will become as 4, this will come as 4. So every time you put anything here, real number, it will always be positive. So this will be the range. So range will be R plus. That is set of all real numbers which can be 0 or greater than 0. It can never be less than 0. So you can write x belongs to R and x is always greater than or equal to 0. Next one is gx equal to sin x, and we know that sin x always is between minus 1 and plus 1. Sin x will always be between minus 1 and 1, right? Inclusive of this. So the range will always be between minus 1 and 1. So you can just write x belongs to R, x is between minus 1 and 1. Third one is hx equal to x square plus 1. Hx equal to x square plus 1. So whenever you add anything, you can put 0, because real number can be anything. 0, minus or plus. Always positive will come and it will be always plus 1. That is always greater than or equal to 1, because 1 is already added. Whatever you do here, it will be always greater than 1 because 1 is already here added. So you can say range of hx is x belongs to R and x is always greater than or equal to 1. Next question is x is given as 1, 2, 3 and 4 and y is given as 1, 5, 9, 11, 15 and 16. So you have to find out whether these are sets or these functions or not. So this f1 is 1, 1, 2, 1, 3, 1, 4, 15. So if you see here, 1, 2, 3, 4 all belong here and they are not repeated. 1, 11, 1, 15, 1, 11, 1, 15 all belong to here. So there can be repetition, but here it should not be repetition. First member cannot be repeated, so it is a function. Second one is 1, 1, 2, 7, 3, 5. So 1, 2, 3 belong here, 1, 2, 3 belongs here. 1, 7, 5, 1, 5 belongs here, 7 does not belong here, so it is not a function. Next one is 1, 5, so 1, 2, 3, 4, 2, oh, here 2 is repeated. You cannot have in function the first member of the ordered pair repeated, so it will not be a function. You just stop here. Next one is A is given as 12, 13, 14, 15, 16 and 17. And the function f is from A to Z. That is this from A to any this integer. Z is integer. Now fx is given as, what is fx is given as? Fx is given as highest prime factor of x. So what we'll do, we'll try to find out the factor of these members. And we'll take the highest prime number. So how do we do it? 12 can be written as 3 into 4, 13 can be written as 13 1, 14 7 to the 14, 15 5 into 3, 16 2 into 8, 17 into 1. So in this is the not prime, so 3 will take. Here 13 and 1 is not prime, so we can take 13. 7 and 2. 7 and 2 both are prime, but we have to take the highest prime factor, so we'll take 7. 5 and 3 both prime, we'll take 5. 2 and 8, only 2 is prime, so we'll take this one. 17 and 1, only 17 is prime, we take 17. So what will be the ordered pair? 12 3, 13 3, 14 7, 15 5, 16 2, 77. This is the ordered pair. Now range also need to be found out, so you just pick the second member of the ordered pair. Okay, so this will be 3, 13, 7, 5, 2 and 17, like this. This will be the range. Next one is, if it is given f is from real number to real number. It is defined by, fx is defined by x square plus 1. So we have to find out the f inverse of 17. So f inverse is 17. So just put this f inverse. Whenever we have f inverse y, this x will belong to A, that is this one, and fx equal to y. When you put f inverse y equal to x, when you take inverse here, y will be fx. Okay, inverse comes here, it will become f. So y will be equal to fx. So when you put this equal to, say, this is a f inverse 17, and we know that this fx is x square plus 1. So let me put it as x. Okay, f inverse comes here, so 17 will be f of x, and fx is what? X square plus 1. 17 becomes x square plus 1. 1 goes here, x square will be 16. So x will be plus minus under root 16. This will be plus minus 4. So plus minus 4 is there. In order to find out same thing, means same logic will use, f inverse minus 3. This is equal to x. So f inverse goes here. So fx becomes minus 3. Fx is what? X square plus 1. X square plus 1. 1 goes here. So x square will be equal to minus 3 minus 1. It is going to be x square equal to minus 4. But there cannot be any square which gives you negative number. So this is nothing. So your f inverse minus 3 will give you nothing. So it is empty. You just write empty. Now let A be PQRS and B be 1, 2, 3. Which of the following from A to B is not a function? Is not a function. So it's easy to check now. We know the function quite clearly. So it is quite easy to check. How? First see. PQRS. So all PQRS first member, they are different, they are unique and they belong here. The second member 1, 2, 1, 2 belong here. So it is a function. Now coming to this one. PQRS. All are different and they belong here. 1, 1, 1, 1 doesn't matter. It is belonging to B, but it may be repeated. So it is also a function. Coming to third. P1, Q2, P2, S3. So here this P, the first member of these two are repeated. So it is not a function. We cannot have repetition in the first member of the ordered pair. So this is not a function. Come here. P2, Q3, RS, S2. So P, Q, R, S, all they are unique and they are also belonging to set A. And 2, 3, 2, 3, they may be repeated, but they are belonging to set B. So this is a function. Only this is not a function. Now given as A is given as 9, 10, 11, 12 and 13. Right? Now let F be from A to N. From this A to the natural number. Defined by, now definition is the same. The highest prime factor of N. So we have done the question of this sort just now. So what we will do, we will take these numbers and try to find out the factors, the prime factors. So we have to have a prime number. So 9 can be written as 3 into 3, 10 is 5 into 2, 11 is 11 into 1, 12 is 3, 4 and 13 is 13 into 1. So what is the highest one? They both are prime. So you can take 1. They both are prime, 5 you can take. 11, 1, 11 is prime, 3, 4, 3 is prime, 13, 1, 13 is prime. So what will be the ordered set? 9, 3, 10, 5, 11, 11, 12, 3 and 13, 13. This is the ordered set. This is the function actually. And what is the range? The second member, 3, 5, 11, 3, 13. So just 3 is repeated, you just write it once. Otherwise 5, 11 and 13 will be there. 3, 5, 11, 13. This next member or the second member of the ordered pair of a function, it is the range. Now a function is defined like this. Fx is defined by fx equal to x square when x is between 0 and 3. So 0 and 3 belonging means it is less than or equal, so 0 and 3 are inclusive. It is x square. When it is from 3 to 10, we'll use 3x. Okay, but this 3 is inclusive here also, 3 is inclusive here also. Same thing for gx. First let us find out for fx. We have to find out that f is a function, g is not a function. So whether f is a function, let us check. So we'll check at the border level 3. So I'll put f3. Okay, we'll put f equal to 3. So when f is equal to 3, we can use this one also because here also 3 is inclusive. So x square, this we are going to use this one. So x square, that is 3 square, it is going to give you 9. Now again f3 we'll find out. Again in this border condition for this one. So again 3 we can take because it is inclusive. Now we'll use this 3x. This is 3 into 3, that is 9. So both the time 9 is coming. So whichever value you will have a unique value for 3, always 9. That is why it is a function. Coming to gx. Gx says what? Gx says that it will be from 0 to 2. From 0 to 2 you will take x square, and 0 and 2 are inclusive. And from 2 to 10 you are going to take 3x. 2 is inclusive and 2 is a border condition also. So we'll choose 2 and we'll find it for 2. So let us put g2 now. Now here g2 will use x square. So 2 square, it is going to 4. Now we'll use this one, and 2 is inclusive, so we can again use this g2 here. Now I'll use this formula or this expression, 3 into 2, 6. So for same 2, 4 is coming, from same 2, 6 is coming. So ordered pair is 2, 4 and 2, 6, and this is not possible. Why? Because the first value cannot be equal. There has to be unique. It cannot be repeated, so it is not a function. Gx is not a function. Now this fx is equal to x square. We have to find out f1.1 minus f1 by f1.1, this 1.1 minus 1. So f1.1 will be equal to, this is x square, so 1.1 whole square. This is going to be 1.21. f1 is what? 1 square, that is 1. So this, let us put it here. f1.1 is 1.21, f1 is 1. 1.1 minus 1.1 minus 1 is already 0.1. So we put 0.1 here. 1.21 minus 1 is 0.21. So we have 0.21 divided by 0.1. 0.21 divided by 0.1, which is 2.1. So this is your answer. Now the set is given as -1, 0, 3, 9, 7. -1, 0, 3, 9, 7. And this fx is, the set x is -1, 0, 3, 9, 7. And this fx is given by x cube plus 1. So we have to find out the ordered pairs. So what we'll do, we'll put -1, 0, 3, 9, 7 here. So when we put -1 cube is -1 plus 1 is 0. We put 0, we get 1. We put 3, 9 is 27, 27 plus 1 is 28. 9. We'll put 9. 9 9s are 81, 81 into 3. It is 9 cube. So 81 into 3, it's 24. 243 plus 1. So it will be 244. And then we have, this is 244. Now 7 sevens are 49. 49 into 3 is 343. 343 plus 1 is 344. So what will be the ordered pair? -1, 0, 0, 1, 3, 28, 9, 82, 9, 244 and 7, 344. So this is the set of ordered pairs. So this is the exercise 3.1 of functions R.D. Sharma, and it includes all the NCERT questions also. Thank you so much. Take care of yourself.